Hello and welcome. In this lecture we are going to create what I showed you on the breadboard in the last video. We're going to use the Tinkercad simulator to do this. So just type in Tinkercad on Google and you'll see tinkercad.com. Just click that. And you're going to want to sign up, right? But I already have, so I'm going to sign in. And I'm going to sign in with Google. And then you'll see 3D designs. We don't want this, we want circuits. You see circuits down here, just click circuits. Okay? And then press create new circuit. Once you've done that, you should see this blank screen. To the right, you'll see components. Scroll down until you see breadboard small. Click it once. Move where you want it to be and click again. This is our virtual breadboard. You can use your middle mouse wheel to scroll in and out of the circuit. I'm going to move my breadboard to the left here, and I'm gonna select the Arduino Uno R3. I'm going to click it once. Left click again to place. Now, for the time being, we're just going to power our circuit via the Arduino's 5-volt port and ground ports here. These ports are very useful for providing power to your circuits. The power comes in through the USB, powers the Arduino, and the Arduino gives us a nice 5-volt output to power our circuits. You could also use a battery. I now want us to zoom back into our circuit. We're going to left click on the 5-volt pin. You'll notice this. What is this? This is a wire, a virtual wire. Now I just want you to bring it down a bit. Left click again to stop, and it'll bend the wire like this, as you can see. Scroll out with your middle mouse wheel, and we're going to put this into our plus on the breadboard here. Into the first pin that you see. Left click, and there we go. And you'll see this color, and it's currently green. I want to change to red to represent power. Okay. We do need to connect our negative terminal as well. So here you'll see a ground pin here, right? The negative terminal should always go to the ground pin. So let's left click on ground. Left click again here. Scroll out with middle mouse wheel, and we are going to put it into our negative terminal on the breadboard, and we're going to change the color to black. Okay, so you should see something like this now, and what this is doing is it takes power from the Arduino and it runs the power all the way down this track here, so all the way down the plus, all the way down the negative, and the middle of the circuit here is not powered at all. Okay, so now that you've done that, let's actually put a light emitting diode in our circuit so that we can light the bulb up. So all you need to do is left click the LED, and we are going to put it here at the top of our circuit by there. Now this is an LED. When you pass power through it, it lights up basically. Now you'll notice two legs on the LED. You'll notice a straight leg and a leg that's bent. Now when you buy these LEDs in real life, the longer leg usually represents the positive terminal, right? And the shorter leg represents the negative terminal. So this is how you need to connect them up. Now the actual length of the leg here, they're the same length, but you can see that it's bent a little bit. Because in the simulator the leg on the LED is bent a little bit, that is a signifier that we should connect our positive terminal to that leg of the LED. So let's just connect that now. And if this is a real circuit, by the way, do not follow what I'm doing right now because your LED will explode. I'm just keeping it simple for the time being. So we're going to left click there, and we're going to left click here. Okay, so this transfers power from our positive terminal here to this line on our breadboard. So it will power this line only. All these other lines will not be powered. Please see the breadboard video to see how power goes through the breadboard, because I explain it in detail. Now our negative terminal here, we need to connect that one to this leg. So once again, the negative terminal will line up on this entire line. Okay, so what's going to happen when we start the simulation then? Let me explain. The power is going to come in through the Arduino from the computer using the USB. 5 volt is going to come through here. It's going to come down this entire line. This wire here, this green wire, it's going to go through here, all the way through this line, through our LED, causing it to explode in real life. So don't run it in real life. And then it's going to go, and then the current's going to go through this leg here that's straight, back up here, and then it's going to travel all the way back up, all the way back into the Arduino ground. So that's just a demonstration. Now I'm going to press start simulation. You can do this too. And you can see that it has lit up, but it has a symbol of an explosion. The simulator is telling us that if we run this circuit in real life, our LED will explode. Or smoke up or break. You know, basically it'll damage the component. I'm now going to show you how you can prevent these LEDs from exploding. Now firstly, why do they explode? Well, we are passing 5 volts straight into that LED. And that's just too much current. It's just too much current. The LED can't handle it. It explodes, smokes up, breaks. So we need to provide some sort of resistance in our circuit. And there's a little component in electronics that is called a resistor for doing just this. Now we're not going to go too much into resistors on this tutorial. This is essentially just a hello world to electronics. But anyway, we will put the resistor there, but you won't really understand how it's working. This will be explained in another lecture. So left click the resistor, and we're just going to place it, okay? Now, currently, this is wrong. It shouldn't be placed like this. If you go to the left here, you'll see this little icon. This means to rotate. Just click it twice or 3 times. 3 times should do it. Okay. Now drag this and place it by here. And delete this wire as well. You can do that by selecting it and pressing the delete key on your keyboard. Okay, if you press start simulation now, it will not work. The LED doesn't light up. This is because we no longer have our positive line going into our LED. Now, just to keep things simple, let's change the color of this wire here to black, just so we know that that's for our negative terminal. Just to keep it simple, okay? So what we're going to do now is we're going to create a wire from our positive to this resistor by here. So let's first stop our simulation, and then we're going to left click here, and we're going to drop the wire here, and we're going to change the color to red. Okay, if we now press start simulation, we see that our LED lights up. It's very dim, but it doesn't explode. Now, again, what's happening this time is the current's traveling from our computer here through the USB into the Arduino. There's then power coming out of the 5 volt port here, the pin, and it travels down our breadboard up to this wire, through here, and then it goes through our resistor. Okay? And then it goes up here, through the LED, down here, and then all the way back to the Arduino ground. Now bear in mind, it's important that this, I explained the difference between the legs on the LED. It's important you get it right because these are diodes, and diodes only allow current to flow one way. If you was to flip the legs around so that the bent leg, the longer leg, is on the negative terminal and the straight leg is on the positive, the LED will never light. Okay, so I just want to clear that up. Now, essentially the resistor, it slows down our current, right? So that the LED doesn't have an insane amount of current pass through it, causing it to explode. Now, there's many types of resistors, and you have to pick the right one for the component you're using. This is actually the wrong resistance for an LED, which is why it's so dim. I'm just going to change this resistance to 250. And we're going to change it from the K ohms here to just the ohm. Okay? And this is the correct amount of resistance for this LED. So the question you're probably asking is, well, how do you know what resistance to use on what components? Well, there's a thing called Ohm's law for calculating this, but we'll go more onto that in detail later on. So congratulations, this is your Hello World LED example. I hope you enjoyed this tutorial. You should now have an LED that's lit. And if you perform this exact circuit in real life, you will also see a real LED lighting up. So before we end this tutorial, I've remade our circuit in a simulator that shows exactly what's going on. Now this is a schematic run through a simulation. Let me just stop the simulation here. This here represents a resistor. This here is our power. And this here is our LED. Okay, so this is how it's drawn on schematics as well, but more on that later. You can see here the positive terminals here is represented by the longer line, and the negative terminals represented by the shorter line. So current flows through here, through our 250 ohm resistor, through our LED, and then back to our negative terminal. So if I just run the simulation, you can see what's happening. The current's going through the resistor, which slows it down, through our LED, back to ground. Now I'm just going to change the resistance value to 10, something really small. You can now see the current sped up. It is now sped up quite a lot. If I change it to 100, we can still see that it's faster than if it was 1000 ohm. 1000 ohm resistance, we can see the LED's barely lit. The current is going very slow. Set that to 10k ohm. Now, the LED's barely even on. Put it back to the resistance at 250 ohm. We can see that the LED's lit again. So hopefully that explains how resistors slow down current. But we will go much more in depth on that later on. Okay, thanks for watching this video. Thank you for watching this part of the course. You can find the next part in the video description.